What are the chemical structures of isotactic, syndiotactic, and atactic polystyrene? In isotactic polystyrene, the phenyl groups are on the same side. In syndiotactic polystyrene, the phenyl groups are on alternate sides. And in atactic polystyrene, the phenyl groups are randomly placed. Now let's do syndiotactic. This is atactic. What are the chemical structures of cis and trans-polybutadiene and the 1, 2, and 3, 4 structures of polyisoprene? Cis 1,4-polybutadiene is the hydrogens are on the same side of the double bond and the polymer chain continues on the other side of the double bond. Trans 1,4-polybutadiene is so the hydrogens are on the opposite sides of the double bond and the polymer chains are continuing from either side of the double bond. Now part B, isoprene is also called as 2-methyl 1,3-butadiene. So the numbering is 1, 2, 3, 4. In 1, 2 addition we get this is 1, 2 polyisoprene and 3, 4 polyisoprene is got from 3, 4 addition. How do head-to-head and head-to-tail structures of polymethyl methacrylate differ? In the head-to-head structure, the carbons containing the methyl and the methacrylate group are adjacent to each other. This is head-to-head. In the head-to-tail structure, the carbon containing the methyl and the methacrylate groups are on alternate carbons. Show the structures of statistical and alternating copolymers of vinyl chloride and ethyl acrylate. In statistical copolymer, there is a statistical distribution of the mers of vinyl chloride and ethyl acrylate. So this is poly vinyl chloride, stat ethyl acrylate. There is no set pattern and the mers are statistically arranged. In alternating copolymer of vinyl chloride and ethyl acrylate, you can find the mers of vinyl chloride and ethyl acrylate in an alternating fashion. So this is poly vinyl chloride, alt ethyl acrylate. Cis-polyisoprene has been totally hydrogenated. What is the name of the new polymer? So cis-polyisoprene is this. Upon hydrogenating, so this is a propylene group and this is an ethylene group. So we got a alternating copolymer of propylene and ethylene. So this would be polyethylene alt propylene. What are the two possible triblock copolymer structures of polybutadiene and cellulose? The two possible triblock copolymer structures are of the type ABA and BAB. So in this case, it would be polybutadiene block cellulose block butadiene. The other one would be polycellulose block butadiene block cellulose. Using table 2.6, calculate the run numbers and average sequence lengths for the two polyethylene stat 1-hexene copolymers. Do they indeed appear to be statistical copolymers? First, let's calculate the run number. So the run number is given as half of He, which is EHE, ethylene hexene ethylene sequence, plus half of the sequence ethylene hexene hexene. If we plug in the values that are given in table 2.6, EHE is 0.098 plus half of EHH is 0.053. This is for the 8317 copolymer. So we get 0.1245 and that's the run number. Now let's calculate the average sequence length. For the E sequence length, we need to first find out E and divide that by the run number. So E is given as EEE plus HEE plus HEH. So the values for these sequences from the table is 0.620 plus 0.164 plus 0.043. That gives us 6.64. That's the average E sequence length. Now, moving to the H sequence length. The H sequence length is given by the sequence HHH plus EHH plus EHE over the run number. So that would be 0.022 plus 0.053 plus 0.098 over 0.1245, which is 1.39. The sequence lengths are 6.64 for E and for H 1.39. So this looks like appears to be statistical copolymer. Moving to the next copolymer, which is 97/3. Let's calculate the run number, which is half HE or half of EHH plus EHE. Half of EHH is 0.000 plus EHE is 0.031. So the run number is 0.031. Average E sequence length that is E over run number, and E is EEE plus HEE plus HEH. Plugging in the values, 0.908 plus 0.061 plus 0.000. .26. That's the average E sequence length. The average H sequence length would be HHH plus EHH plus EHE over the run number. So that is, the values are 0.000 plus 0.000 plus 0.031 over 0.031, which is 1. So the average H sequence length is 1. So from the numbers for E sequence length and H sequence length, this does not appear to be statistical distribution. A graft copolymer is formed with polybutadiene as the backbone and polystyrene as the side chains. What is the name of this material? A graft copolymer of A and B is named like this: poly A dash graft dash poly B, where A is the backbone and B is the graft. So in this case it would be polybutadiene dash graft dash polystyrene, because polybutadiene is the backbone and polystyrene is the side chain or the graft. Chemical nomenclature forms the alphabet of polymer science. A. What is the chemical structure of isotactic polyvinyl chloride block cis-1,4-polyisoprene? B. Polyvinyl acetate is totally hydrolyzed. What new polymer is formed? What polymer is formed if the hydrolysis is only partial? So this is a block copolymer with one block of isotactic polyvinyl chloride and another block of cis-1,4-polyisoprene. So it should be like this. There's a block of isotactic polyvinyl chloride followed by a block of cis-1,4-polyisoprene. Let's write the structure of isotactic polyvinyl chloride. In isotactic polyvinyl chloride, the chlorines are on the same side. And so on. This is the cis-1,4-polyisoprene block. And so on. So note that the chain is on the same side of the double bond because this is cis. So this is the structure of isotactic polyvinyl chloride block cis-1,4-polyisoprene. Part B. Polyvinyl acetate is totally hydrolyzed. What new polymer is formed? So polyvinyl acetate is CH2, CH, OCO, CH3, and this is hydrolyzed usually with alkali and methanol. If it is fully hydrolyzed, it forms polyvinyl alcohol. If it is partially hydrolyzed, some of the acetate groups become OH groups and some of the acetate groups would remain. So it would be and so on. So this is partial hydrolysis, and this is total hydrolysis. So we can say that on partial hydrolysis, gives a copolymer of polyvinyl alcohol and polyvinyl acetate. In the accompanying structures, P1 is polyvinyl acetate, P2 is polyethyl acrylate, and P3 is polystyrene. What are the chemical names of these structures? The first one is so we have a block of P1 followed by a block of P2. P1 block followed by P2 block. So that would be P1 block P2. So we name it as polyvinyl acetate block polyethyl acrylate. Next is we have a P1 polymer chain, that is a backbone, and from there we have covalently bonded side chain of P2. So P1 backbone and covalently bonded side chain of P2. So that would be P1 graft P2. So the name is polyvinyl acetate graft polyethyl acrylate. The next is so we have just one polymer P1 which is cross-linked. So cross-linked P1, so that's called as net P1. So the name is net polyvinyl acetate. Next one is we have cross-linked copolymers with P3 linked at both ends to P1. This is a cross-linked copolymer with P3 linked at both ends to P1. So it would be P1 net P3. So the name is polyvinyl acetate net polystyrene. So we see that there are two polymers, P1 and P2, which are not covalently bonded to one another. They are just blended, but they are both cross-linked polymers, but they are entangled with each other. So they are entangled combination of P1 and P2 that are cross-linked polymers they are not bonded to one another, not bonded to one another. P1 and P2 are not covalently bonded to one another, but they are interpenetrating. Network. So they would be named as cross P1 inter net P2. So it will be cross polyvinyl acetate inter net polyethyl acrylate.